Today we are going to do a lesson on sigma notation. Now sigma notation is what you see in the examples below with that little E symbol. That E symbol is actually a capital sigma. An indicated sum of the terms of a sequence. So if you have a sequence and you add them up, it is known as a series. The notation that we use to write a series is sigma notation. And we use that little E symbol, or it's a sigma. And let's look at a couple problems here. Write each arithmetic series as a sum of terms, then find the sum. So if you look, it says n equals 1 up till 5 of 3n. What you're going to do is you're going to plug the numbers 1 through 5. So 1, 2, 3, 4, and 5 into the n and add up your answers. So if I show my work, it would be 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 9 is 5 is 15. Add them up and you'll get 45 as your answer there. I am going to leave this one for you because it's an easier one to try. Let's do the other two together. So this one says here, n goes from 2 to 5. So I'm going to plug the numbers 2, 3, 4, 5 into the n. The I I'm just going to leave as an I because it doesn't say to plug anything in for that. So it'll be 2 squared plus 2i plus 3 squared plus 2i plus 4 squared plus 2i plus 5 squared plus 2i. So that's 4 plus 2i plus 9 plus 2i plus 16 plus 2i plus 25 plus 2i. Combine like terms, the numbers combine to 54. Then the 2i's all add up to 8i. So 54 plus 8i is your answer there. This one on the right hand side, this one says h goes from 1 to 6. So wherever I see an h, I'm plugging in the numbers 1 through 6 and adding them up. So it'll be negative 1 to the first times 1 plus negative 1 squared times 2 plus negative 1 cubed times 3 plus negative 1 to the 4th times 4 plus negative 1 to the 5th times 5 plus negative 1 to the 6th times 6. Alright, negative 1 to the first times 1 is negative 1. Negative 1 squared times 2 is positive 2. Negative 1 cubed times 3 is negative 3. Negative 1 to the 4th times 4 is positive 4. You probably see the pattern, minus 5 plus 6. When you combine all this together, you get 3 as an answer there. Alright, let's look at the others. This is going the other way around. This time I give you the sequence and I'm asking you to write it in sigma notation instead. Let's look at actually this fraction one first. For this fraction one, it's easier to separate the numerator from the denominator. Notice the numerator goes from 1 till 9 in order, and the denominator goes from 2 to 10 in order. So watch what I do here. I'm going to say n starts at 1. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So I'm going to say n goes from 1 to 9. The numerator is just the n value. The denominator is 1 more than the n value. So n plus 1. Okay, so if I plug a 1 in to check my work, 1 over 2. That's the first term. If I plug a 2 in, 2 over 3. And I keep going, I would get 9 over 10 as the last one. So that's the sigma notation for this one. Let's look at the other fraction one as well. I, for some reason, think fraction ones tend to be a little bit easier than the other types. So I'll start with the sigma. I see I have 1, 2, 3, 4, 5 terms. So I'm going to say n goes from 1 to 5. And I see the numerator hasn't just the n value. Now the denominator, you have to look to see, well, what would I do with n to get to a 3? And maybe you say add 2. But then you have to follow the pattern. And now it would be 2 plus 2 would be 4. That doesn't equal the 9. So maybe you say times 3. So 1 times 3 is 3. 2 times 3 is 6, not 9. What is actually going to work is going to be 3 to the nth power. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. And 3 to the fifth is 243. But do you notice one thing on this problem? It goes negative, positive, negative, positive, negative. When it changes between the negatives and the positives, you have to include negative 1 to a power, in this case the nth power. If your odd terms, first, third, fifth terms, odd terms are negative, it's to the nth power. If your even terms are negative, you would put a little plus 1 afterwards. But it's not, so we just leave it as an n. Now let's go back up to the first one, and I'm actually going to leave the fourth one for you guys to do, because that one should not be too difficult. If I look at the first one, I have 7 terms. So I'm going to say n goes from 1 to 7. Now I have to figure out how to get from 1 to 3. This 1 to that 3. Maybe you say add 2. So then you take the second term, which is 2, and add 2, it equals 4, not equaling that 5. And you could try a lot of different things. What's going to end up working is, and more than one thing may work, 2n plus 1. Look what happens. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9, and the pattern does continue. So this is our final answer for that one. At this point, you can try the 2 skip problems.